Hi everyone, thank you for coming here and sitting and watching. My name is Seth Proctor. I'm the CTO at NuoDB. I'm going to give folks just a few seconds more to come in, to find a seat, to make sure that everyone can see what we're demoing. I just want to let folks know also that we have a booth. It's right back over there. It's 233, I think. If you walk back in the 200 aisle, you can't miss it. It's full of bright green cranes and people who are all wearing exactly this outfit. So most of them look better in it than I do, but we're right over there. And I mention that for two reasons. One, because you should totally go by if you're interested after this talk and learn a little bit more about what we're doing through NuoDB. NuoDB is a pretty interesting, complicated piece of technology, and I'm not going to go deep into the architecture in this talk, but hopefully you're interested and you want to learn more. The other reason you should come by is because I'm going to give a pretty high-level demo here. I want to really just highlight a few very basic elements of what NuoDB is and what makes it kind of fundamentally different. But sitting at our booth, we've got a nice big display. We've got a demo going with some pretty interesting workloads running against the database, and we can actually talk with you one-on-one and show you interactively what's going on. So hopefully this gets you excited. Please, if this is interesting, I'm going to try to end a little bit early, so that gives you a few minutes at the end. You can use that time to come by the booth, to meet us, to learn more about the product. So just show of hands, how many people here have heard of NuoDB? Okay, good. That's a good start. So for those of you who have not heard of us, in addition to branding things with origami cranes like crazy, in our spare time we also make a database. NuoDB is it's a relational database. It turns out SQL still exists, especially in the cloud. It's increasingly critical. Transactions, asset properties, being able to have a true database is really fundamental to a lot of infrastructure, especially here in New York City. Hello, New York City. What's interesting about NuoDB, what's fundamentally different, is that we've started from scratch architecturally. We've basically said, if you want to solve all of those hard transactional SQL asset problems, but what you want is an architecture that scales out. Something that can scale on demand, something that works in a cloud model in terms of provisioning and monitoring and management, something that can run multi-data center, something that has a security model built in, has a management model built in, has an operations model built in. That's where we started, essentially. And that's why we're here at Cloud Expo, because what we really have is we have a relational database that is designed as a distributed system to solve all of those interesting cloud problems that probably most of you care about, because that's why you're here. And so what I want to do is I want to introduce you briefly to NuoDB, and then I want to show you NuoDB actually running, doing some of those cloud things I'm talking about. So, just as important background, for those of you who have not looked at our database, we designed our database software as a peer-to-peer architecture. Right? And that means it's highly resilient, that means it's very easy to scale, that means there's no single points of failure. It's a pretty nice architecture in terms of working in a cloud environment. Each of those peers essentially plays one of two roles. There are peers that are responsible for doing transactionality, for actually speaking to SQL clients, for running SQL transactions, for making sure the database stays consistent, doing all that kind of good stuff. And then there are peers that are responsible for data durability. And between those two peers, you end up with a full database. And then essentially what you can do to make a database scale is you can add to that transactional tier, which is an in-memory caching tier. If what you want is you want additional transactional throughput, if you want to be able to handle more clients, if you want availability and access to your database in multiple locations. And you can scale to that, you can add to that durability tier if what you care about is multiple points of redundancy and availability of your data set. I say all that to give you a little bit of context of what you're about to see in terms of software. The first thing I'm going to actually demo may seem kind of uninteresting, but I think in the database world this is kind of cool. So the first thing I'm going to do is I'm going to install NuoDB on this laptop I have here. Right, so important to understand, NuoDB is a piece of software. It's not a hosted service. It'll run on Linux, Windows, Mac. It'll run on my Mac laptop here, it'll run on your desktop, and it'll run in the cloud. And obviously that's where we're going. But just for context, one of the things that we're really passionate about at NuoDB is how we simplify software, how we make it really, really easy to get running with a database. Because most of you don't want to be database administrators, right? You have problems you want to solve. So, I've got the Mac package installer here. There's another green crane. We should have been. Where's Michael? Michael, we should have been running a contest, like count the number of green cranes that show up in the talk. So I'm going to go ahead and just install the software. And the reason I'm doing this, as boring as this is exactly because it's so boring. So I'm going to install the software. Done. Right? And to be clear, this isn't like a desktop version of the software, right? What I just did was I installed the full suite of our software. I installed the 64-bit server. I installed all of our drivers, all of our examples, like everything is now running on my machine. And that took me 10 seconds, right? So please, if you're curious about our software, go try it, because it's really that simple to get up and running. Interestingly, I don't have a database running on my machine yet. What I've done is, in the cloud sense of the word, I've provisioned my laptop. I've made it available from a monitoring and management point of view. And now I can choose to run 1 database, 5 databases, 100 databases on this machine. And what's popped up here is another green crane, and a series of demos just to kind of get you started. So some examples to kind of help you play with some schemas, see that it's really a SQL database, an application that lets you kind of start kicking the tires and actually see it running in practice. An administrative console that lets you immediately start addressing this machine, start working with it, start actually running some databases. A simple graphical explorer so that you can start walking through and see that it's really SQL. Probably most of you don't actually want to see me sit here and type like select star from whatever, but I assure you, like we do have a command line tool and you can just like type select star from system.tables, you know, or you can type show tables for that matter, if that's the way you like to do it. So, really simple to get going, but probably most of you aren't very interested in my laptop as a private cloud. So, let's do something a little bit more interesting. I feel like this is like on the cooking show where I'm going to be like, you bake a cake and then 45 minutes later it comes out like this. Before the demo, what I did was I spun up some instances on Amazon. And for those of you who are familiar with working in Amazon, these aren't particularly high-end special instances. What I've actually got... Why don't they... There we go. So what I've got running is kind of a bunch of R3 instances. For those of you who are kind of familiar with the new instance classes, these are memory optimized. NuoDB is an in-memory database. That means you can take advantage of these kind of new instances that Amazon has that are pretty low cost in terms of hourly and yearly rates and are wicked efficient for running the database. So I've got a bunch of instances running, and just like installing on my laptop, basically I logged into an instance, just did an RPM install, done, got the software running. And then I started bringing several instances online. I started provisioning them, started making them available to run. And once I've done that, once I provision those instances, I can now go and run this neat little web console we have against the system, right? And if any of you were in my talk earlier, you heard me say that tools are nice, but it's the APIs underneath that really matter, that's what you want to integrate with. So we do have a nice GUI, we also have a nice command line interface. It's all built on top of APIs that are available through REST, through Python, command line, Java, on the theory that most of you probably, as you're trying to scale this out and kind of do enterprise heavy lifting, you're going to want to integrate monitoring into your own tools. You're not going to want to use these, but hopefully these are kind of a nice way to get you started. Plus, there's another green crane up there. And what's nice about this, kind of what I want to illustrate, is I've got stuff running on Amazon right now. I've got multiple instances running. But because of the way we have a kind of a monitoring and provisioning model built into the software, from a single place, and securely, mind you, see I'm logged in here as me, through a single secure interface, I can actually address all these resources. right? And that means I can do things like say, I really want to monitor, total network traffic through all the instances that are going down. Let's do like a breakdown by 5 minutes. So I can just simply say like, let me pull up another graph so that I can see something about what's happening across the system, right? So this is a very simple way that we let you start to script and automate the process of not just seeing what's happening in your database, but from a systems administration point of view, what's happening across what we call the domain, kind of all the provisioned resources. All right, so what can I do given that I've got a domain provision, I've got some resources provisioned? Well, this is a database, so presumably what you want to be able to do is create a database. So another thing we've done in NuoDB to make your life easier is we assume that you want to be running a distributed system. You want to be running a database that's actually made up of these peer-to-peer processes across lots of hosts. And it turns out that's hard. Like, for anyone, even distributed computing nerds, like it's really hard to think about running lots of things in a secure fashion, configured correctly, yada, yada, yada. So what we've built into the product is something we call templates. And templates, basically what this is this is a declarative language. This is a way for you to define the SLA that you want. What is the problem you're trying to solve? Do you want to get a quick database spun up for testing? Do you want something that's minimally redundant, where any host can fail and your database is still there? Or do you want something that will scale on demand up to some number of hosts to give you kind of the transactional capacity you need? Or do you actually want to run in what we call a geo-distributed format? Do you want to run across multiple data centers? And so, let's see, I can do this. I can start a database, and all I'm going to do, if you're familiar with RDS, this is kind of like if you could strip down RDS to the simplest elements, right? I'm going to give my database a name. I'm going to pick an initial DBA username and password, and I'm going to pick which template. So let's start out with that minimally redundant example. I'm going to hit submit. And what this is going to do is it's going to go off, and it's going to find 4 hosts to use to run a database, right? And I didn't have to do anything more than that. So if we go to databases here, I got this database called Expo, and there it is. It's running, in Amazon sense, it's running in a single region. Click through, we can see it's actually running in US East, so that's in Virginia. It's a database that's made up of 4 of these peer processes, what we call storage managers and transaction engines, and you can drill in and see all the gory details, but you don't have to, right? Because you know it's made up of 4 processes, it's running on 4 hosts, and because I started it through this template, not only did I get the database up and running, so I know I got it set up correctly, but you can see up here, it's active, right? So we're monitoring them. So we've given you kind of a cloud service out of the box, right? If that's what you really want, and this is like a single REST call, this is a single Python invocation, like however you want to script it. But if you want to start getting databases spun up on the cloud, this is what makes that really simple to work with. I'm not going to worry about driving load to the database right now. Again, we're demoing that in our booth. Please come by and see that it actually, like, you can do stuff against the database. What I want to talk to you today really is focused on kind of this operation and understanding some of the interesting problems you can solve. All right, so we're going along. We have a database where any host can fail, and you're still going to have a complete copy of the data available to you, and you're still going to have an in-memory component that lets you talk SQL to the database. And that's really cool, but maybe your application is starting to evolve, and what you really care about is you care about being able to scale it out. Well, I can go back to my list of databases, and I can edit it. I can say, you know what, minimally redundant was great, but what I really want now is I want a multi-host database. I want it to scale on demand. So you can go to that live database and you can say, I want to change the template for my database. You don't have to be hardcore systems admin. You don't have to be some like distributed systems wonk. You can just come up and say, like, that's what I want, right? And now it's reconfigured itself. It's running in a better scale-out model. It's giving you new capacity and new capabilities. Now, something that's really cool that I haven't shown you yet is that while this database is only running in one region, what I actually spun up before this demo was I spun up instances in 3 Amazon regions. Right, so probably most people know this, right? But US East 1, that's Virginia. US West 1, that's California. US West 2, that's Oregon. right? So I've actually got NuoDB running in 3 physical Amazon regions. I've only got the database right now, remember, running in Virginia, but because of our provisioning model, I can address all of these systems, and I can treat this as a common pool of resources to run a scale-out database. And that means that I actually can say, well, all right, let's go back to my list of databases. And now my little Expo database, it's growing, right? And it's grown beyond what it can do in one region. And what I really want is I want it running in a geo-distributed fashion. I want it running in all 3 of those regions so that I get low latency, so that I get data redundancy, so that I get resiliency in the case of any one of those regions completely failing. And I go ahead and hit submit. Right, and what's going to happen is there's going to be some communication for a few minutes while kind of hosts across Amazon talk to each other. We're going to get some new processing spun up, and very quickly, we're now running in a new configuration, right? And to be clear, this really, like what you just saw is real. This is really actually running on Amazon, right? And I've now just taken a database, I've started in a small configuration, I've grown it, and then just by point and click, I've said, you know what? I actually want this database physically running 3 regions across the continent, across 12 hosts. To a database developer, this looks like a single logical database. It's one JDBC connection string, right? Or one PDO connection string, or one .NET connection string, whatever the API is that you want to be using to talk to it. There's no sharding, there's no active-passive model, there's no notion of data being active in one region but not the other. All SQL clients can address the system exactly the same way. And so your application didn't have to change as I changed my operations model. So I'm actually right now running a single logical database that is transactionally consistent, and for most workloads, highly low latency. And again, come by the booth so you can understand we're not claiming that we've subverted the laws of physics. We have our heads screwed on straight about what you realistically can and can't do. I think this is pretty cool. But there's one more thing I want to show you. Because you're at Cloud Expo, Amazon may not be your thing. There may be other things you're particularly interested in. And so, one other thing I want to show you is what I've got sitting over here is I've actually got 2 virtual machines that are provisioned on SoftLayer. And so the SoftLayer booth is over there. You can go talk to the SoftLayer guys, pretty interesting technology. But what I'm going to do here is I'm going to start up those 2 new instances. We're still seeing, all this data going and going. And before we were watching host network traffic, and we're seeing it broken down by region. And you see when I brought in those new things, we're seeing this little blip here because there's now a 4th region that's available. And from the point of view of monitoring regions, we now have a new thing called US Central. Well, guess what? There is no US Central in Amazon. This is actually SoftLayer instances that are running in Texas. And so what I just did was, if we go back and look at the databases, and we look at Expo, without changing anything to my database configuration, I just brought online new instances on SoftLayer that are talking over secured connections to the instances I already had running on Amazon. And because I had started my database against an SLA, against a template that said this is the problem I'm trying to solve, that database automatically expanded to take advantage of those SoftLayer instances. So now I have a database running in 4 geographic regions across 2 different public clouds. And from a SQL point of view, it looks like a single database. And your application developer is just sitting there writing code and doesn't care. I think I'm at the end of my time. I think this is wicked cool. And I hope you all do too. I hope this was kind of interesting. I don't think there's any other database out there that you can do this kind of thing here today. And so I hope if you have questions, I'll hang around. Please come find me. Please come over to our booth. We'd love to show you this actually running under load. We'd love to talk about some of the use cases this is particularly valuable for. But if you're interested in the ability to run a database in cloud, public cloud, private cloud, if you're interested in a scale-out database that runs across multiple data centers, multiple physical regions, if you're interested in hybrid cloud environments, if you're interested in simplicity and still getting transactions, I hope this has been interesting. So again, my name is Seth Proctor, and thank you very much, everyone.